In this video, we'll learn how to create a playlist system to handle background audio. To start out, we'll create a new script, and we'll call it bg_playlist. And once you've done that, go ahead and open it up. To start off, we will create a new using statement, and we will add system.collections.generic. Then we'll go to variables. First will be a list. This is what we will use to hold our audio clips. So go ahead and type in audio clip. We'll call it my list. And it will equal to a new audio clip list. Next variable will be a public int. Call it my iterator. Set it to 0. In the start function, we'll set our audio clip to my list my iterator, which is set at the beginning since we have it my iterator set to 0. And then we'll play it. After that, we'll go into our update function. First, we will check if our audio is done playing. If it is, then we'll need to check if my iterator is greater than or equal to the capacity of our list. If it is, then set the iterator back to 0. If it's not, then we'll iterate our iterator. Then at the end, we'll set our audio clip to our current iterator, and then we'll play that audio clip. What this will essentially do is go through our list and play each audio clip, and then when that audio clip is done, we'll move on to the next one. Once you've done that, go ahead and save it, and we'll go test it out. Now to test this out, you need a camera and add an audio source to it. To add that, go ahead and add our script. And we have 3 music files, so we'll make our list to be 3. And go ahead and drag our audio clips into it. Once you've done that, press play and we'll see what happens. As you can tell, it went through the list, starting at the beginning, then went to the bottom, then went back up. Play through all of them, and you will get this error down here. It's nothing to worry about. All it's telling you is that the iterator went past the size of the list, but we already handled that by having it set back to the origin, which is the beginning of the list. You shouldn't have any problem with your code. And with that, you have successfully created a playlist system to handle audio background music. In this video, we will learn how to create a collision-based system to play and handle our background audio. So to start off, we'll create a new script. Call it bg_collision. Once you've done that, go ahead and open it up. To start off, we will declare our audio clip variables. First one will be my town. The next one will be my building. And the last one will be my normal. In our start function, we will play our normal audio clip. So we'll assign our clip to my normal, and then we will play it. And in our on trigger enter, we will check for collider, which we will call other, and we will use a switch statement to check what we collided with and what its tag is. First case will be town, and here we'll set our clip to my town, and then we will play it. Next case will be building, and we'll do the same as we did before, so we can just copy and paste this down. And we'll assign our clip to my building. After that, we will do our trigger exit function. And we'll check for other collider again. First, we will set our clip to normal, and we'll play it. So what this will do is it'll check when we collide with an object, and if that object's tag is town, it will play the audio clip set for town. And if we collide with the object with a tag of building, it'll play the audio clip that we have designated for building. And when we leave either one of these clips, it'll play our normal audio clip like we did in the beginning. And once you've done that, go ahead and save it, and we'll go test it out. To test this out, you'll need to add a scene with a few cubes, one for the ground, and 2 for our collider objects. And I have the tag set for that one to building, and this one is town. And on our first person controller, you'll need to add an audio source and our script. Once you've added it, go ahead and assign our clips. You'll also notice we have loop set to true, which means it'll just loop the audio track that's currently playing until we switch it. Once you've done that, go ahead and press play. And you can see that our script worked perfectly. When you collided with each of these boxes, it played the audio clip that we designated for each of them, as well as when you left those boxes, it played our normal audio clip. And with that, you have successfully created a collision-based system that will handle background audio. In this video, we'll learn how to create a situation-based system to handle our background audio. This can be used to tell what situation the game is in or that the player is in, and play background music to fit it. So start off, we'll create our script. Call it BG_situation. Once you've done that, go ahead and open it up. Now that you have the script open, go ahead and start off by creating an enum variable. We'll call it mySituation, and we'll fill it with normal, battle, storm, and cinematic. After that, we'll declare our variables. First ones will be audio clips, one for normal, other one for battle, another one for storm, and the last one for cinematic. And after that, we'll declare our enum variable down here. Call it situation, and we'll set it to normal. After that, in our start function, we will load our normal clip and play it. And in our update function, we will go through all of our situations with a switch statement. First case will be normal, and with this we'll just load the clip in, and we'll actually be doing the same for the rest, so you just copy and paste it. Change that one to battle, then we'll change this one accordingly. This one can be cinematic, and we'll change it down here. And lastly, we have storm. Once you've done that, go past our switch statement, and we'll check if the audio is no longer playing. And if it isn't, we'll go ahead and play our audio. The reason why we check for this is because when you change audio clips, the clip will stop playing, so we have to tell it to play again. Once we've done that, go ahead and save it, and we'll go test it out. Now to test this out, you can either use a first-person controller or a camera. Either way, you need to make sure you have an audio source attached to it, and the loop is set to true. After that, go ahead and add our script, and drag in our audio clips. Once you've done that, go ahead and press play. As you can see, we changed the situation, and it changed the audio clip accordingly and played it. This can be used when the player enters different zones or when he goes into battle. Anytime you need to change the background music through situations, you can use this script. And with that, you have successfully created a situation-based system to handle background audio. In this chapter, we learned how to create a few ways to handle background audio. First way was creating a playlist system. The second way was creating a collision-based system. And the third way was creating a situation-based system. In the next chapter, we'll be learning how to incorporate sound effects. First by coding input-based sound effects, then coding environmental-based sound effects, and lastly by learning how to handle background audio as well as input audio. In this video, we'll learn how to create input-based sound effects. First, we'll start off by creating our script. Name it se_input. And once you've done that, go ahead and open it up. To start off, we can create a couple variables for our audio clips. First one will be called my mouse. The next one will be called my key. In the update function, we will check if input.get button up. We'll check for fire 1. After that, we will assign our audio clip to my mouse, and then we will play it. You can copy that whole if statement down. We will change fire 1 to jump, and then we'll change my mouse to my key. The first if statement, we're checking if fire 1 has been pressed, which is the left mouse button. If it is, it'll play the my mouse audio clip. Then after that, we're checking if the jump button was pressed, which is the spacebar. And if that is pressed, it'll play the my key audio clip. Once you've done that, go ahead and save it and we'll go test it out. To test this out, you can just create a simple scene with a first-person controller. Make sure there's an audio source attached to it, and make sure these are all checked off as false. Next, add our script. Then we will need to assign our audio clips. I'll put this one for my mouse, and for my key, I'll use this one. So now, let's go play it. And to start off, I will use the left mouse button to test the my mouse audio clip. You can tell it played the sound. And now I'll test out the jump input, which is my key. Do that by pressing the spacebar. And with that, you have successfully created input-based sound effects. In this video, we will learn how to create environmental sound effects. So to start off, we will create our script and call it se_environmental. Once you've done that, go ahead and open it up. To start off, we will need to create a new using statement, which will be system.collections.generic. After that, we'll create our variable, which will be a list, and it will contain our audio clips. We will call it my list and set it to new list audio clip. It should come up. And in our update function, we will check if audio is not playing, If it is, we'll need to set our audio clip. We will go through our list randomly, which will give us a new sound effect each time it plays. We will access random.range. Our minimum will be 0 since our list starts at 0. And the maximum will be our list capacity. Then after that, we will play it. Except this time, we will add a 1 second delay by putting 44100. What this is doing is taking the sample rate and it'll add it into here. So this is the delay right here. Usually the sample rates are about 44.1 hertz. So if you were to put 44100, it would delay it by 1 second. If you were to do 2 seconds, you would just multiply that by 2, which would be 88,200. You could keep going on more and more if you want to delay it more. Once you've done that, go ahead and save it, and we'll go test it out. To test this out, we'll first need to create a basic scene with a first-person character and a floor for it. Then we'll need to create a new game object. I will create a sphere. Just drag it a little further away from the character. Once that is done, you'll need to add an audio source to it. Check off play on awake. Then we can add our script to it. For the size of our list, we'll go with 4. And we can add these in and make sure that all of them are 3D sound. Make sure that is checked off. If it's not, then it won't play in 3D space. So here this one is not, so check it on. Hit apply, and it'll convert it into a 3D sound. We'll use that one, put there. Use that one. That. And we'll use this one. Now it's ready. Go ahead and press play. As you can see from the test, it played all of our sound clips randomly in our list. I also took into effect the 3D sound aspect of it by making sure I went around the sphere, not just in direction, but in distance. The further away you were, the quieter it seemed, and the closer you are, the louder it seemed. Also, when you go to the left or right side of it, the sound effect will only play in the left or right side, depending on your angle. And with that, you have successfully created a script that implements environmental sound effects. In this video, we will learn how to manage background music and input sound effects at the same time. So to start off, we'll create a new script. Call it SE_BG management. Once you've done that, go ahead and open it up. To start off, we'll need a couple variables. First one will be an audio clip. Call it my sound. The next one will be a float. We'll call it my volume and set it to 1.0. In the update function, we will first look for a game object. And we will look for BGM_controller. We'll access the audio source of that game object, and then the volume, and we'll set it to my volume. After that, we will check if input.getButtonUp fire 1. So we're checking if we press in the left mouse button. And if that happens, we will set our audio clip to my sound, and then we will play it. Reason why we're looking for the background music controller in the update function is so that we can change the volume dynamically in our script. Once you've done that, go ahead and save it and we'll go test it out. To test this out, you'll need to first create an empty game object, which you can do right here. Name it BGM_controller and add an audio clip. Make sure it's a 2D sound and make sure these two are checked off: play on wake and loop. And on our first person controller, make sure there's an audio source and make sure these are all checked off as false. And then we can add in our script. We can add in our sound effect as well. I'll use this one. Right now our volume is at 1, which is the maximum. To change the volume, you can change it between 0 and 1, as you can see here. So we'll keep it at maximum for now and see how it turns out. Now let's change our volume to half as much. So now when you test it, the background music will only sound as half as loud. And you can also change it while the game is running. As you can see from the test, we successfully changed the volume of the background music to enable our input sound effects seem louder. You can do this for not just background music, but also any other sound effects to make different ones seem louder than the others. And with that, you have successfully created a script that handles background music and input-based sound effects. In this chapter, we learned how to use different types of sound effects. First was input-based sound effects, then we implemented environmental sound effects, then finally we learned how to manage background music while using input-based sound effects. In the next chapter, we'll learn how to create a 2D parallax background. First we'll create a basic parallax background, and then we'll add in character movement, and finally we'll make an advanced 2D parallax background. In this chapter, we'll be learning how to create a basic 2D parallax background. So to start off, we'll create our script, and we will call it parallax_basic. And once you've done that, go ahead and open it up. To start off, we'll need to create a couple of variables. The first one will be a float. We'll call it scroll speed x, and set that to 0.1. Next one will also be a float, and we'll call it scroll speed y. Set that to 0.1. In the update function, we will be creating a couple more floats. First one will be called offset x, and we'll set it to time.time multiplied by scroll speed x. And as you can tell, we'll be doing the same for y. So set this one to offset y. and change this to scroll speed Y. After that, we will need to access this GameObjects renderer, then its material, and we will make it do a set texture offset. In this first part, you need a property name, which is the name of the shader. For a diffuse, which is what we will be using, you'll need to put in underscore main text. And for vector 2, we will use the values of our offset variables, so offset x and offset y. And what's going on here is that every time the game updates, our offset variables will be set to a new value, which is the current time that is passed in the game, multiplied by our modifier variables, which is our scroll speed. And then down here, we set the position of our texture on the material to a new value each time, which is offsetting it, making it look like it's moving. Once you've done that, go ahead and save it, and we'll go test it out. To test this out, you will need a plane, a camera, and a light. Make sure the plane has a texture on it, and that the plane fills out the camera. Go ahead and drag our script down. The values look good. So let's press play. As you can see, it's parallaxing right now. If we were to take out the Y and set it to 0, it'll only move in the X. To change the direction, just make it negative. We can do the same for Y. And with that, you have successfully created a script that creates a 2D parallax. In this video, we will learn how to emulate character movement within a 2D parallax background. So to start off, we'll create our script, call it parallax underscore movement. Once you've done that, go ahead and open it up. To start off, we need to create a couple variables. Both of them are floats. First one will be called scroll speed x, and we'll set it to 0.005. The next one will be offset x, and set that to 0. In our update function, we will check if input.getButton horizontal, which is essentially checking if the left or right arrow is being pressed. And inside there, we will check which one we pressed by checking if input.getAxis horizontal. We will check if that is greater than 0.1. If it is, then offset x plus equals scroll speed x. And then you need to access the renderer, the material, and have it do a set texture offset. Then in here, we'll access the main text, which is the diffuse shader. And then for our offset, we'll just be using the x. So offset x, and then for the y, set that to 0. Just copy that if statement down and change this to a less than sign and change that to 0. And down here, change this from a plus equal to a minus equal. So what we're doing here is checking first if you press the left or right button, and then inside there we check which button. This first one is checking for the right button, so the right arrow, and this one down here is checking for the left arrow. Once one of those is pressed, our offset variable is being modified, and then we are setting the texture offset accordingly. The same goes for the left arrow. Once you've done that, go ahead and save it and we'll go test it out. In order to test this out, we will need a plane, a camera, a light, and a capsule. The capsule, I'm just using it as a character placeholder. You use any game object you want. On our plane, you need to make sure there is a texture on it. And we could drag our script onto it. Once you've done that, go ahead and press play. As you can see right now, the background isn't moving. If you were to press left, it would look like the character is moving left. If you were to press right, it would look like the character is moving right. Now it looks to the player that the character is moving around, but actually the environment is moving around the character. This is commonly used in shoot 'em up games. Games that you're in a spaceship or a airplane flying over a background. It looks like in those games that your spaceship is moving around when actually it's the stars and the planets behind it that's making it look like your character is moving. And with that, you have successfully created a script that implements character movement with a 2D parallax background. In this video, we'll be taking our basic parallax background and taking it up the next step by parallaxing the background and the foreground. To do this, we'll need to make two scripts. First one we'll call parallax underscore advanced. And the next one we will call parallax underscore advanced underscore cloud. And once you've done that, go ahead and open both of them up. To start off, we'll be creating a few variables. First one will be a game object. We'll call it myCloud. The next ones are floats. First one we'll call min time. The next one will be max time. And the last one will be next spawn. In our update function, we will run spawner. And after that, we'll create the spawner. First, we'll check if time is greater than next spawn. If it is, then next spawn equals time plus random.range min time and then max time. So essentially what it's doing so far is checking if the current time is greater than the next spawn. If it is, then next spawn is being set to the current time plus a random number between our minimum and max number. After that, we will need to instantiate a new game object. Our game object will be myCloud. Our position will be transform.position. And our rotation will be myCloud.transform.rotation. And what that line is doing is instantiating a new game object at this current game object's location, and it's setting the rotation of that game object to its default rotation. And once you've done that, save it, and we'll write the script for our other one. To start off, we'll need to create a new variable. It'll be a float, and we'll call it speed, and we'll set it to -0.01. In our update, we'll just need to access the transform and have it translate. And for this, we'll just be doing our x coordinate, which will be speed. Our other ones will be 0. And all this we'll do is make our cloud, when it spawns, move left. Once you've done that, save it, and we'll go test it out. To test this out, you'll need a plane, a camera, and an empty game object. The empty game object needs to be placed in front of the background and off to the side, so that when you spawn your clouds, it doesn't just look like the clouds are popping onto the screen. And on our empty game object, we'll add in our advanced script. For the game object, we need a prefab. And for our times, the minimum time we could have at 15. And our maximum time could be 45. And on that cloud prefab, you need to make sure you have the cloud script attached to it. And on our background plane, you can add the basic parallax script to it. Make the Y 0. We can make the X a little faster, set to 0.2. Once you've done that, go ahead and press play. And as you can see, our foreground is moving a little slower than our background. This will give the appearance that it's a separate object, and it enhances the realism of your game. And with that, you have successfully created a script that steps up the basic background parallax. In this chapter, we learned how to create a 2D parallax. First, we made a basic parallax background. Then we implemented some character movement. And then we brought our basic background parallax up another step and made a foreground parallax as well. In the next chapter, we'll be learning how to create a 3D parallax. First, we'll learn how to create the 3D parallax, and then we'll implement some character controls, and lastly, we'll learn how to jump with our character. In this chapter, we'll learn how to create a 3D parallax background. To start off, you'll need to create a basic level. I've made mine completely out of cubes. We will also need to drop in our character. I'm using a capsule. And adjust it so that it's in front of the camera, kind of in the center of it. That looks good right there. Once you've done that, duplicate it. We'll name this one 3D Parallax Character Controller. Then we'll name the other one Player. Once you've done that, grab the player and the main camera and drop them into the character controller. The reason why we're doing this is so that when you're rotating the character, you're not rotating the whole camera. See, if we just rotate the character, that's all you get. When you do the whole thing, you're moving the camera as well, and we don't want that. We also don't need a mesh renderer. for our character controller. And once you have done all of that, it is now ready to be coded. In this video, we will be writing the code for our character movement. So we'll need to create a script and call it Parallax Character Movement. Once you've done that, go ahead and open it up. To start off, we'll need to create a few variables. First ones are public floats. Call one of them player speed and the other one gravity. The next one will be a private vector3. We'll call it direction and we'll set it to 0. In our update function, we'll first get our character controller, call it myController, and we'll have it get the character controller component. After that, we will check if our controller is grounded. If it is, direction will equal new vector3 input.get axis horizontal for our X position. Our Y will be 0 and Z will be input.get axis vertical. After that, we'll set direction to transform direction, and our new direction will be our direction vector3. Then finally, direction will times equal player speed. After that, we'll set our direction.y to minus equal gravity times time dot delta time. And then at the very end, we will actually move our controller with myController.move with direction times time dot delta time. Once you've done that, go ahead and save it and we'll go test it out. To test this out, we'll first need to drag our script onto our character controller. We'll set speed 5 and gravity to 20. We'll also need to give our character controller a character controller. Let's go to physics and character controller. When this pops up, hit replace. Once you've done that, go ahead and press play. Now you can see you can move left and right, as well as forward and backward. And our character will collide with everything else. And with that, you have successfully created a 3D Parallax character controller. In this video, we'll be adding a jump mechanic to our character controller, so we'll need to start a new script. Call it Parallax Character Jump. Once you've done that, go ahead and open it up. First thing that we will need to do is copy our previous script over. This is so that we will have our character movement. After that, we'll be adding some new variables. One will be jump speed, and the other will be a boolean, and we'll call it can double jump, and we'll set it to false. In our if statement, we will set can double jump to false. This is for when the character is on the ground. And at the bottom, we'll need to add if input dot get button up. We'll need to check for jump. We'll set our direction dot y to jump speed and set can double jump to true. Then here we'll add an else statement. So when he's in the air, we'll check if can double jump is true. And then we'll have to check again if input dot get button up jump. And you can actually copy this code over into that if statement, but this time set can double jump to false. Once you've done that, go ahead and save it, and we'll go test it out. To test this out, we'll need to drag our script over, set player speed to 5, jump speed to 10, and gravity to 20. Whenever you're setting the jump speed, always make sure it's less than gravity. If not, then the player will never reach the ground. Once you've done that, go ahead and press play. And you can see we still have our character movement. And if you press the spacebar, you can jump. And if you press the spacebar again while in the air, you'll be able to double jump. And with that, you have finished creating your 3D Parallax character controller. In this chapter, we learned how to create a 3D Parallax background. First we created the Parallax background, and then we implemented character controls. In the next chapter, we'll learn how to create an enemy character controller. We'll start out by creating a state-driven AI system, and then we'll incorporate the character animations. In this chapter, we'll be creating an enemy character controller. To do this, we'll be using a state-driven system, which is a simple yet effective way to handle enemy AI. So to start off, we'll create a script, call it enemy state controller. Once you've created it, go ahead and open it up. Once you get the script open, go ahead and clean it out. We'll start off by creating an enum, call it eState, and we'll only have 4 states, which are idle, patrol, attack, and die. So done that, go ahead and create the variable for it, call it state, and we'll set it to idle as a default. In the update function, we will run a check state function, which we will create later. After that, we will create the set state function. This function is used by outside scripts to set the state of the enemy. And here we'll set state to the state received by the function. Finally, we create the check state function. We'll check the state by using a switch statement. First case will be attack. And here, we'll have it send a message to itself to attack. What it's doing is telling the AI part of the enemy to run the AI for attack. And for debug purposes, we'll have it log attack. For the rest, you can just copy and paste and do the small adjustments. After attack, we have die. So we'll change that to die. And we'll change the log to die. Next one is idle. Go ahead and change that to idle. And lastly, change that to idle. The last state, we have patrol. Do the same. Change that to patrol. Change the log to patrol. Once you've done that, go ahead and save it and we'll test it out. Now to test it out, you can go ahead and drop in a character controller and give it the enemy state controller script. By default it's idle. Go ahead and press play and it's idling. And make sure they all work. Make sure the log and the debug is according to the state. And it looks like they all are, so they all are working. And with that, you have successfully created an enemy state controller. In this chapter, we'll be reading the code for the animations that our enemy will have. Start off, we'll create a new script. Call it enemy anim state controller. Once you've done that, go ahead and open it up. Once you have the script open, go ahead and go back into the state script and copy and paste everything in it. Put it into our new script. Make sure you grab the enum variable. And we will have to rename our enum. We'll just add a 1 at the end of it to make it easier. The reason why we're doing this is because you can't have more than one enum with the same name. Once you've done that, we'll be creating our new variables. First one will be an animation variable. Call it underscore animation. The next 4 variables will be animation clips. We'll do one for each of the states. The next one is patrol. Third one will be attack. And the last one will be die. After that, we'll create some float variables and set them to 1. We'll do one for each of the animations. This is to control the speed of the animation. And with them being a public variable, you can adjust them in the editor easily. Once we have that, go down here to our states, and we can take this out, and we'll start off by setting the speed of our animation. So underscore animation, then we'll access the animation itself. For the first one, we'll do attack, access the name, dot speed, set that to our attack offset. Next, we'll set our wrap mode. This one will set to loop. You see different ones here. This clamp forever will play into the last frame and then it'll freeze the last frame. Default will just be whatever your default setting is in your animation. Loop will loop the animation. Once will play it once, and ping pong will go back and forth. It'll start from the beginning to go to the end, and then it'll play from the end to the beginning. But for now, we just need loop. Then finally, we'll play it by using a crossfade. A crossfade will essentially crossfade this animation into the previous one it's played. That makes it look smoother. And we could just copy and paste it into the next one and change these out. This one is die, so we'll change all the names to die. And we'll change our wrap mode. Instead of looping, we'll do clamp forever. Do the same for idle. Make sure it loops. Change that to idle. And finally we'll do patrol. Make sure it's looping. Once we have all that done, save it, go back into the editor. Make sure it compiled correctly and there's no errors. And with that, you have successfully written the code for animations. In this video, we'll be testing out the animations that we made for our character. So to do that, you need to make sure you have a camera and some lighting in the scene. Then we'll check on our model. Make sure he has animations. If you need to add them, press the plus button. Take away, press the minus button. When you're done with that, click apply. Then go into the rig. Make sure the animation type is set to legacy. If it is, leave it. If it's not, set it and click apply. After that, drag him into the scene. Position him in front of the camera. There he is. Rotate him around. That's pretty good right there. Once you've done that, make sure he has an animation component on him. If not, you can go up here, click components, go to miscellaneous, and click on animation. Make sure play automatically is not on. Then go ahead and add our animation script. Click on the animation component and drag it into our animation variable. Go into the model itself and drag in the animations to their appropriate name. Once you get all of that, go ahead and press play. You can see now he's animating. You can actually move him closer so you can see better. Right now he's idling. You can change his state to patrol and he'll start patrolling. And since the animation is set to loop, it'll go back to the beginning flawlessly. Make him attack. Then die. And since our wrap mode for die is clamp forever, it stays at the last frame. Set him back to idle. You can change the speed of the animation. Make it go a little faster or slower. And the animation will change accordingly. Make it really fast. Now that you have done that, you successfully have animated your enemy character. In this chapter, we learned how to create an enemy character controller. First started off by creating a state-driven system for our enemy, and then we created animations for those states. In the next chapter, we'll learn how to create AI for our enemy. We'll start off by creating a patrolling AI, then we'll create a stationary AI, and then we'll implement some dynamic behaviors for those AI. In this chapter, we'll be creating different types of enemy AI. To start off, we'll be creating a stationary AI. To do this, go ahead and start our script. We'll call it enemy AI stationary. Once you've made that, go ahead and open it up. Once you have the script open, go ahead and clean it up. We'll start out by declaring a transform variable. We'll call it target. And in our update function, access the transform and the lookat method. And we'll be using this overload, transform target, and the vector3 for our target. We will use our target transform variable and our vector3. Our vector3 is used for what axis is used to rotate in. We will use the y-axis. And once you got that done, go ahead and save it and we'll go test it out. Now to test it out, we'll first need to create our enemy. I will create a enemy capsule, move it over, and I'll also add a cube to the capsule, just so that we have a reference to its rotation. Add that capsule to add that cube to the capsule. Once you got that, we'll also need our target. For our target, I will use a sphere. Click on the capsule, drag over our stationary AI script, then drag over your target to the transform target variable. And once you got that done, go ahead and press play. Now whenever you move the sphere, the capsule will rotate to it to look at it. And it will always be rotating in the y-axis, since that's what we set it for. This can be used for tower defense games, or if you have a stealth game, this can be used for security cameras. Or say you have a sniper, an enemy sniper, and he needs to stare at an object like a car or the player. And with that, you have successfully created enemy AI stationary. In this video, we'll be creating a patrolling enemy AI. So to start out, we'll create a script, call it enemy AI patrol. Once you've done that, go ahead and open it up. Once you have the script open, go ahead and clean it up. We'll start out by creating some variables. First one will be a transform array. Call it waypoints. Next one will be a float. Call it speed. Next one will be a int variable, an integer variable. Call it current waypoint. After that, create a boolean variable. Call mine do patrol. And set it to true by default. The next few are going to be vector3s. First one is called target. The next one will be our move direction. And the last one will be our velocity. After that, we'll create our update function. And here we'll first check if our current waypoint is less than the length of our waypoints array. If it is, target will equal waypoints cure waypoint dot position. So this is setting the target to the current waypoint. Our move direction, we target minus our current position, and the velocity will be rigidbody.velocity. Then we will check if move direction dot magnitude is less than 1. If it is, cure point plus plus. If not, then our velocity equals move direction dot normalized times speed. And we move on down. So if our current waypoint is less than, our current waypoint is greater than the length of our waypoints, then it will check if do patrol is true. If it is, current waypoint is 0, basically resetting it. If not, then our velocity is going to be set to 0, which would be vector 3.0. And after that if statement, we'll set our rigid body velocity to the velocity variable, and we'll make this object look at our target. Once you have all that, go ahead and save it, and we'll go test it out. Now to test it out, we'll have to create a few game objects. First one we'll create will be our enemy. We'll name it enemy. Then we'll need to create our waypoints. And we'll use spheres. Go ahead and get an overhead view. We have one there, and one there. I'll rename these as well. Waypoint 1, waypoint 2, and waypoint 3. A little more. There. And we'll also need to turn off the collider on all these. Now our enemy, we'll need to add a rigid body to him. And take off use gravity, since we're not going to be using gravity. And add in our patrol script. Waypoints, we have 3 of them, so set 3 to the size. And drag in your waypoints. And speed, I'll put 10. Once you get that, go ahead and press play. So you can see, our enemy is going through each of the waypoints, making it appear as he is patrolling. Slow him down. Give him a nice slow patrol. And with that, you have successfully created a patrolling enemy AI. In this video, we'll be implementing some behaviors to our enemy AI. To start out, we'll create a new script. Call it enemy AI behaviors. Once you've done that, go ahead and open it up. To start off, we'll need an enum. Call it states. States we're using our patrol, flee, chase, and stationary. We'll go ahead and create a variable for it. Call it AI states. We'll set it to patrol by default. Next, we'll need a transform variable. Call it T target. Then we'll need a vector 3. Call it V target. In our update, we'll use a switch statement to go through our states. So, switch AI states. First case, chase. Then we'll run a chase function, which we haven't created yet. You can copy and paste for the rest. Next will be flee. We don't have that function yet, so we'll have to create it later. Next up is patrol, and it will run a patrol function. And finally stationary. Once you've done that, we'll create our patrol function. And for our patrol, we'll take our code from the patrol AI that we created earlier, bring it in, get everything within the update function, bring it into our patrol, except take those out, and put them into our update, and take this top half of the if statement, minimize that, and we'll create our chase function. Change our if statement to check for if our current transform dot position is not equal to our target transform dot position. Then we'll assign our vector3 target variable to our transform target position. Change that to our vector3 target. That's fine. This, let me switch this one around. Take that from there and put it up here. Take out the else. And we'll need an else statement here. Set our velocity to 0. And go ahead and take that top part of the if statement again. Minimize the chase function. We will now create the flee function. Essentially do the opposite of chase. And the best way to do that is just change it from a minus to a plus sign. And for our stationary, we'll set our velocity to vector3.0 so it stops moving. And once you've done that, go ahead and save it, open it up in Unity and test it out. Now to test this out, we'll need to create a target for our enemy. Move it off to the side. Then we'll need to assign our script, assign our target to our target transform, assign our waypoints, set our speed. So you got that, go ahead and press play. You can see right now our state is set to patrol, so our object is patrolling. If you're to make it stationary, it'll stop moving. Set it back to patrol, and he'll continue patrolling. If you're set to chase, it will now go after our player. And move our player around, and still chase it. If we were to set it to flee, it will run away. And set it back to patrol, and it'll keep patrolling the way it was. And with that, you have successfully implemented some behaviors to our enemy AI. In this chapter, we learn how to create enemy AI, first by creating a stationary AI, then a patrolling AI, and then we implemented some behaviors to that AI. In the next chapter, we'll be learning how to create some level changing systems. First will be a collision-based level changing system, then a GUI-based system, and then a random level changing system. In this chapter, we will learn how to change levels. To start off, we will learn how to change levels with trigger-based collisions. To start off, we'll create a script call it level changer collision. Once you've done that, go ahead and open it up. Once you have the script open, go ahead and clean it up. We'll start out by creating our only function, which is an onTrigger enter function. Our collider will be other. First thing we need to do is check if the tag of the other game object is level changer. If it is, then we will change the level by accessing application.loadLevel. We can use either the name of the scene or the index of the scene in the build settings. For now, we'll just use the name of it, which is level change 1A. Once you've done that, go ahead and save it, and we'll go test it out. To test it out, we will need to drop in a character controller, and we'll need to duplicate our scene and change it to 1A, same as it was in the code. And to make sure it's the same, double click on it to load it. We'll need to drag in our first person controller, make sure it's there. And now go back to the first one and drop in another game object. I'll use a cube. Raise it up. There it is. I'll make it a little bigger. Let's call it changer. We'll need to add a new tag. Tag will be level changer, like it was in the script. Now tag changer with level changer, and make sure it is set to trigger. Now on first person controller, drag over our script, make sure it's on there, and press play. Now it's not going to work, and that's because we need to add our scenes to the build settings. So add the first one, add the second one. Now let's test it again. And it works. Change the level to the next one. You notice that there's no cube in here. And with that, you have successfully created a collision-based system for level changing. In this video, we will be learning how to change levels by using the GUI. So to start out, we'll create a script, call it level changer GUI. Once you've done that, go ahead and open it up. Once you have the script open, go ahead and clean it up. Start out by creating the onGUI function. And here we'll need to check if a GUI button is clicked. So if GUI.button rectangle, create a new rectangle. Our left position will be screen.width divided by 2. And our height will be screen.height divided by 2. That's essentially putting the button in the middle of our screen. For our width, set it 100, and our height for our box, set it to 30. And the text for our button will be change level. Here we'll check if application.loaded level is equal to 0. If it is, then application.load level 1. And this will be drawn from the index of levels instead of using the actual name. Then we'll check again if application.loaded level. If it is, then application.load level 0. This is just setting it so that we'll check if load level is 0, then go to level 1, and if we press the button and we're on level 1, it'll go to level 0. Once we've done all that, save it and we'll go test it out. Now to test this out, first we need to make sure our levels are in our build settings. So we got level 0 and level 1. Then we'll apply our scripts, GUI, save it, and then go into the next level and drag our script onto our first person controller. Make sure it's there, save it, and press play. So on level 1A, there's no box. Press change level. We have now gone to our first level, which is a box. And if you press it again, it'll go back to the other level and there's no box. And with that, you have successfully created a level changing system using the GUI. In this video, we will learn how to create a random level changing system. So to start out, we'll create a script, call it level changer random. Once you've done that, go ahead and open it up. Once you get the script open, go ahead and clean it up. In our update function, we will check if input.getButton up, and we'll check for jump, which is the space bar. And if it is, then application.loadLevel random.range. For our minimum, we'll put 0, and our maximum, we'll put 6. And after that, we will log in our debug application.loadedLevel to string. Now so we know what level we're on. Once you've done that, go ahead and save it and we'll go test it out. Now to test this out, we'll need to add our script to our first person controller. Go to scripts, level changer random. Now we'll add that. Now save the scene and go down here and duplicate the scene. You could just select it and press Ctrl D and do it so that we have 5 levels. Then go to our build settings and add the levels. We can actually make one more and add that to the build settings. There, so we have 5 other levels. And once you've done that, press play. So right now we're on level 0, which is the first one. Here, press spacebar. We are now on level 4. Press spacebar again. Back to level 4. Do it again. Now we're at level 2, so it's doing it randomly. Now we're at level 1. Level 3. 2. 2. 3. 2. 0. 1. And 3. And with that, you have successfully created a level changing system that uses random numbers. In this chapter, we learn how to change levels by using collisions, the GUI, and by randomly changing levels. In the next chapter, we will learn how to create an item carryover system. First by creating player prefs for the items, then we'll create a save system for the player prefs, then a load system for the player prefs. In this chapter, we will be learning how to create a carryover system for items. This system will be used to save and load items between your levels. To start off, create a new script. We'll call it inventory prefs. And once you've done that, go ahead and open it up. Once you have the script open, go ahead and clean it up. We'll start out by creating an enum, call it weapon, and we will fill it with staff, sword, and axe. And to start off down here, we'll be creating our variables. Call this first one will be our enum. We'll call it iWeapon. And for default, we'll have it at staff. Our next variable will be a string, which is our weapon name. And the ones that we'll be using are wooden staff, iron sword, and steel axe. Keep that in the comments so we have a reference. Next one will be an integer. Call it gold. This will be how much the item is worth. 10 for the wooden staff, 20 for the iron sword, and 40 for the steel axe. Our next variable will be a float. Call it damage. This will be how much damage the weapon will have. Our wooden staff will have 15, the iron sword will have 30, and the steel axe will have 60. Go ahead and save it. In the next video, we'll pick it up and learn how to save our variables to player prefs. In the last video, we created the variables that we'll be using for our item. Now, in this video, we'll be creating a function to save our variables to our player prefs. So, call this void save prefs. We'll start out by using a switch statement for iWeapon. First case will be staff, and in our break, and first we'll set a weapon name to wooden staff. Take from our comment from earlier. Next will be the gold, which is 10, and our damage, which is 15. Now you can take and copy and paste that for the other two, and make the appropriate changes. This one is sword. Copy the name down. Change the gold to 20, and the damage to 30. Final one is X. Copy the name down. Change the gold to 40 and the damage to 60. Now that's done. This is the player prefs part. So we'll go player prefs dot set float, and when you're setting a player pref, you have the key and the value. The key is the name of the player pref. So for our float, we'll do PP damage, and our value will be our damage float variable. Do it again. Next one will be int for our gold. So our key will be PP gold, and our value will be gold. And lastly, we have our string. This one will be PP weapon name, and our value will be our weapon name string. Once you've got that down, save it. And in the next video, we will learn how to load the prefs and test it out. In the previous video, we learned how to save our player prefs. In this video, we'll be learning how to load our player prefs, and then we'll be testing it out. To start off, we'll create a new function and call it load prefs. We'll start out by loading our player prefs into our variables. So first will be our weapon name. That will equal player prefs dot get string. We'll need to use our key, which was pp weapon name. Next up, we'll do gold. Set that to player prefs dot get int, and the key was pp gold. And finally, our damage will be set to player prefs dot get float, and our key was pp damage. After that, we'll need to change our enum variable. We'll do that by using a switch statement on weapon name. Our first case will be the staff, so take wooden staff from up here. Then we'll set iWeapon to equal weapon dot staff, and put in the break. You can copy and paste, then we'll adjust accordingly. Next up is iron sword, so we'll change that to dot sword. Then finally we have our axe. Change this to dot axe. And that is it for our loading prefs. To test this out, we will need to set up our update function. We will check if input.get key keycode.s. So this is checking if you press S on your keyboard. If you do, we will run save prefs. We'll do another one for input.get keycode.l. So we'll be checking if you press L on your keyboard. And when you do, we will run load prefs. Once you've done that, go ahead and save it, and we'll go test it out. To test this out, we'll need to assign our script to our main camera. And we'll change our default to sword. Save the scene, and we'll duplicate it. And to make sure it's duplicated correctly, we will check if our script is on here, which it is. Go back to the first scene, click on your camera. So right now it's at sword, press play. Click in the play area just to be sure that we're testing it. Right now you don't have any stats, so we haven't saved it, so go ahead and press S. We now have an iron sword with a gold of 20 and damage of 30. We are to change it to axe and save it. We'll have a steel axe, 40 of gold and 60 in damage. And staff, save it. It will be wooden staff, 10 gold and 15 damage. To make sure this is working correctly, load up the other level and run it. Click in the play area to make sure you're working in the play area. Press L to load our player pref. The wooden staff popped up because we saved that previously. And let's change it to sword. Let's change it to axe. Click in the play area, press S. We now have our axe saved. Go back into here, our previous level. We'll run it. Don't have any stats, but when we load our player prefs, our axe will pop back up. And with that, we have successfully created an item carryover system. If you're watching this video, then it must mean you have completed the Mastering Unity 4 Scripting video course. In this course, we learned how to create a background audio controller and incorporate sound effects. Then we moved on to creating a parallax background, both 2D and 3D. Then we moved on to creating an enemy, first by giving it a character controller, and then giving it some AI. After that, we learned how to create some level changing systems, and finally, we learned how to create an item carryover system. I hope this video course has helped you a lot, and good luck on your future projects.